Hello, today I'm going to be doing a axisymmetric simulation of a small pipe injecting fluid into a much larger pipe. So we're going to look at the development of that jet as it progresses downstream. You'll notice that I've already loaded started a new STAR-CCM simulation. This is because I'm using a power on demand license key file that I don't want you guys to see what it is. But you would start your STAR-CCM file by loading STAR-CCM, and you can go to File, New. It'll give you the options for however you load it, whether it be through a license file or a power on demand file. Once you start it, you're going to come up to this screen. If you don't have this property files down here, that's not that big of a deal. Everything that I do down there, you can actually get by double clicking on everything up here. I'll show you an example of that in a second if you don't understand what I'm talking about. But if you want this down here, what you can actually go to Windows and actually just click on Properties, and it'll show up. It might show up somewhere else. You can click and drag it to wherever and orient these windows however you want. So anyways, the first thing we're going to want to do is create some geometry. So if we expand the geometry, right click on 3D CAD models and click new. It's going to load this plane. We're going to be doing an axisymmetric 2D modeling. So we need to make our sketch in the XY plane. If we made it in the with the Z plane, essentially, whenever STAR-CCM converts to 2D, it assumes everything in the Z equals 0 plane is what you're using. So it has to be made in the XY plane where Z equals 0. So we can right click on XY plane and create a sketch. Alright, so this comes up. What we want to do, you can set the grid spacing if you wish. What I'm going to do is I'm going to actually change the grid spacing to 0.05 meters. Doesn't really matter. We're going to be dimensioning these anyways, but it's easier for me to click and get more exact. So if you click OK, now we're just going to start making the pipe. I'm going to essentially start the pipe exit. Essentially, I want the pipe exit to be essentially at the origin. So what I'm going to do is at essentially 0.005, y equals 0.005 is where I'm going to make the wall to the outer pipe. And I'm just going to click all the way around, make a geometry that looks something like this. All right, so this is going to be our axis of symmetry. You have some smaller pipe. This is going to be our inlet, and this is the larger pipe that we end up using. All right, so after that, we're going to want to start dimensioning. It should be noted that if for some reason these things are not where you want them to be, so for instance, if these aren't perpendicular, you can actually constrain them to be perpendicular by clicking on one, holding control, clicking on the other, and then right clicking, and you can apply a perpendicular constraint. And you can do that to all of these. I clicked carefully, and since I have snap to grid enabled, which is a default setting, it automatically snapped so that it is already perpendicular. Just to make sure that nothing moves around when I'm dimensioning it, I started everything from this point, and I want that to essentially stay there. So if I right click on it and then right click on it, I can apply a fixation constraint. So now x equals 0 and y equals 0.5. I can't move that. So I'm going to start dimensioning things. What we want is a diameter of the pipe to be 0.01 meters. The radius, since again this is going to be an axis of symmetry, the radius is going to have a length dimension of 0.005. I'm also going to expose that parameter so that we can change it at other times as well as reference it. So I'm just going to call that pipe radius and click OK. Now I want the essentially the other diameter to be 50 times that diameter. So if I right click on that and apply length dimension, I can, if you use the dollar sign, you can actually reference your other exposed parameters. So we're just going to call it the pipe radius times 50. And we're going to expose that parameter as well, just in case we wanted to change it. In this case, we're probably not going to want to, but just in case you want to for anything else, it's always a good idea to add these, so you don't always have to go into the geometry every time you want to change something. By adding these, exposing them, you'll be able to change it without entering this view. So if you can click OK, so you see it got much larger. We also want it to go 50 jet diameters downstream. If you click on it, then right click, and you can apply the jet diameter. We want pipe radius. We want 50 jet diameters, so you multiply the radius by 2. And then, we want 100 diameters downstream. Exposed diameters, I'm just going to call that length. That's fine. So that's much longer. And one more length. So this is for just the developing flow. The longer this is, as long as the pipe is still developing, the pipe flow is still developing, it's going to come in as a uniform flow, and it's going to take some time downstream to develop. So what I'm going to do is click on it, then right click, apply length dimension, and I'm going to call this essentially the pipe radius times, we'll call it 50. That's probably too large. You can probably get away with 20. But if you want it to be fully developed for a Reynolds number, of 1,000, you're going to need about 50 jet diameters. So this is going to be 50 pipe radiuses, which still isn't far enough for it to fully develop. So we can expose the diameter and call that pipe entrance and pipe length. Again, you can change that. The further it is, the more time it has to fully develop. Again, this is just an example, so it's not super important. All right, this is what our diameters. Essentially, this is what our pipe's going to look like. Our two pipes are going to look like. So we can click OK. And so now you can see a sketch. If you click on it, then right click on the sketch, you can extrude. We're going to extrude just a very small amount, so 0.01 meters. And we're going to convert this to 2D anyways, so we don't want a large extrusion. So you can see it's just a very thin extrusion. At this point, you can close the 3D CAD. All right, so now if you expand this further, you can see the bodies. You can see that this body comes right here. You can also see that you can change any of these design parameters. If you look down here, they do reference the values, so you can actually change them to whatever you want from this screen now. But anyway, so if you right click on body, if you open this up, right click on body and click new geometry part, you can just accept these defaults right now. And then just to see what's going on, if you go click up here, you can create a new scene and a new geometry scene. Okay, so this is what our part currently looks like. And let me explain to you about changing the design parameters just one more time. So let's say I wanted the pipe entrance length to actually be 50 times the pipe diameter. If I click down here, I can actually multiply by 2, hit enter. You'll notice there's an exclamation point up here, and actually if you expand this out, there's an exclamation point next to here. If you right click on them and update, you'll see that it automatically got longer for you. So this is a really useful tool. We can change whatever we want by essentially changing these values instead of actually going into the CAD geometry model. You can also, as I mentioned before, if this properties thing isn't here, you can actually just double click on it, and this will come up and you can actually edit it here. Again, it's easier to have the properties down here, but if for some reason you don't want it, you can double click on it. Anyway, so what we're going to do, the first thing we're going to want to do is create a mesh. So if you right click on this, what you want to do is expand the surfaces, the default, we're going to want to break these up into a bunch of different surfaces. So earlier in my other tutorials, I've split by patch at times. I'm actually going to split by angle since everything is a 90-degree angle. So if I click split by angle, the angle in degrees, essentially whatever this is anything greater than this will split into a new surface. So there's only one surface right now. They're all connected. Anything greater than 90 degrees will split into a new surface. So when I click OK, it's now split all these, since they're all by 90 degrees, into a bunch of different surfaces. So the default right here is just the entrance. So we're going to just right click on that, rename it as the inlet. Click somewhere else. This, if you twist it, you actually see is the body on the z=0 plane. So if you right click on that, rename it, you can just call that fluid. This is the default for the top. So when you convert it to a 2D mesh, we're not going to use that. So we're just going to keep it as default 3 because it's going to disappear eventually. Default 4. You'll see right there is the pipe wall. So we're going to right click on that and rename it pipe wall. This down here, you can see it down there, is the axis. So if you rename it as the axis, this is the bottom of the wall for the pipe. So I'm just going to call it bottom wall. And two more. Obviously here is the larger wall, so it's I'm going to name it outer wall. And this is the outlet. So we can rename it outlet. You can rename them to whatever you want. This isn't like Fluent where it automatically assumes that if you name it an outlet, it becomes an outlet. You're going to have to specify that anyways. So there's no real reason to do one or the other. All right, so now that you've done that, if you click on body and right click, you can create a mesh operation. You can click a badge for 2D meshing. You can execute the operation upon creation. I'm not going to do that just so I can show you how to execute it if you don't have it checked. So if you click OK, you notice down here there's an exclamation point under operations. If you right click, execute, now you can see anything with essentially a red outline is a surface, and the solid red is the body. So this is the solid body. These are all the different surfaces. At this point, what we can do is right click again on the body, create mesh operation. We do not want to click a automated mesh. We do not do this. What we do at this point, the order matters. You have to assign the parts to region. And we want to assign the parts to region. We want to create a boundary for each part surface. The other defaults are all right, but we want a boundary for each part surface because we just broke up all the surfaces, so we want to create boundaries for that. If we click apply, and we can close. If we don't do that right in that step, it's going to, if we do that before this step, it's going to assume it's a 3D case, and if we do it afterwards, it's going to get mad at us a little bit when we were trying to assign the regions. So now if you right click on this, create mesh operation, mesh, and you can create an automated mesh 2D. We're just going to do a polygonal mesh with the Prism layer meshing. That's going to enable us to do boundary layers, and we can click OK. You'll see that there's an exclamation point. What we're going to do, you can see what we already chose as polygonal meshes and Prism layers meshes. We're also going to change these default controls. All right, so I kind of have a general idea of what I want to change. The base size, essentially, all these other things are going to reference the base size. So this number is whatever you want to work towards. I'm going to just set it as 0.005 meters. I want my target surface size. I'm actually going to make that quite large. The reason I have my base size so small and then have really, really large percentages for my other default controls is because I want my minimum surface size to be pretty small, and it's all working on percentages. So I have a small minimum size. I could obviously have this a smaller percentage and have my base size larger. but it doesn't really matter because they're all percentages of each other. You can do it however you want. I also am going to change the surface growth rate to 1.15. The number of prism layers for whenever I have them, I'm going to make that 5. Prism layer thickness, I'm going to leave at 33.3. So just check through these one more time and make sure that you have them. Sometimes when you enter a number and you click somewhere else, it doesn't really save it that well. So just make sure that these are the numbers that you want. These are all things that we've changed. Perfect. All right, so now what we're going to do is add some custom controls, because that's going to just give us the same thing on all the surfaces. So if we right click on this, new, we're going to add a new surface control, and we're going to add essentially prism layers on this outer wall. So if you expand this, I'm going to actually rename this outer wall prisms. And I'm going to, right down here, you can see surfaces. I'm going to click the dot 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 next to it, and I'm going to assign that to the outer wall. Click OK. All right, so what I want to do is I want to specify what I actually want to change. I want to change the prism layers, so I can change that to custom. You notice you can now expand that, and you can customize. You can choose what you want to customize. I want to keep the number of layers the same. What I really want to do is change the total thickness. That's really all I want to do for that outer layer one. And I'm going to actually change that total thickness to 100%. That's going to allow the prism layers on this wall to be quite large compared to prism layers down here. All right, speaking of prism layers, that's all we want for that one, but so we can minimize it. But if we create a new surface control, we want to remove some prisms layers on, for instance, the outlet or the inlet or the axis. So we can rename this remove prisms and select the part surfaces that we want to remove. We don't want it on the axis, we don't want it on the inlet, we don't want it on the outlet. You can click OK. You can go expand this all the way down to controls, prism layers, and instead of going to custom, you can actually just disable them. So that's all we need to do for that one. We can minimize that. We also want to make sure that we get a good custom surface size down here, because we want this to be much more refined. So if we create another one, another surface control, and we can just call that, rename that type wall surface. Again, you don't actually have to name this if you don't want, but it's just easier for reference when you go back and change things. So part surfaces, we're going to apply that to the pipe wall. Click OK. Expand this down, and what we're going to change is we want to change the target surface size. We're going to customize this. The target surface size is 10%. And we're also going to add some prism layers here that aren't quite the right percentage what we want. So you can go new, surface control. I forgot. Yep. If you search for the surface control, we can rename this. We can call this bottom wall prisms. The parts we want to apply that to, of course, is the bottom wall. And the bottom wall prisms, the thickness that we want that to be, we can change it to custom, expand it out. We want a total thickness of roughly, we're going to say 400%. Now, I'm using essentially a bunch of the default controls to change the other values I want. If you want more control, you can actually have, for each of these surface values, you could actually change more than one thing. So you could set the exact surface growth rate, the exact target surface size, and the exact prism layer thickness on each surface. That's a more thorough way to do it, but I happen to know that this way is going to work out pretty well. So we're going to keep it with that. So we can minimize everything. And that's all we're going to have right now. So you can right click on this and execute it, or you can also press this button up here that generate the volume mesh. So we can click that. It's going to take a little bit of time to go through and calculate all these. If you scroll down, you actually see that it's calculating a bunch of things. And then once this is done, you'll see that we only have 10,000 cells, which is pretty good. We're going to take a look at the mesh, so we can expand this and change the view to mesh. All right, so you notice that it expands pretty fast. This isn't really what we want at all. This is a very good mesh in this area, but it expanded way too fast. This is not going to give us the essentially resolution that we need in this area. It looks good if this was extended more, but we want this to be more refined. So how we're going to refine this more is we can essentially add a volumetric control. So what we can do is, if we minimize some of these things, what we want to do is create a new part. So right here, we can right click on here and we can create a new shape part. And we're going to create a cone. And so for these cones, the values that I'm going to have for these cones, I'm going to start at 0, 0, 0 with a starting radius of 0.005, and end, essentially the origin of the end circular disk, as 1, and I'm also going to make the essentially the radius of this circular disk 0.15 meters. So if I hit enter on that, you're essentially going to create a cone that starts with that radius. I clicked and changed it, so you can actually do that. Again, we just want it to be 0, and extend all the way out. So we can create that volumetric control and close. And after we create that volumetric control, you can see that there's a cone down here. All right, so now if we look down at the automated mesh, create a new custom control, we can right click, new volumetric control. We want to create a volumetric control on the part on that cone. So for the parts, we click the dot, 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 click cone. And for the controls, we want to customize the size of the 2D surface mesher. You can click check, and you can expand this and change the custom size. We're going to change the custom size to 90%, and then we're going to remesh. So you can either right click on this and execute again, or you can click this button. So it's going to take a lot longer. So I'll be back with you in a second, but it's going to take longer because you're obviously doing much more work. All right, so now that we're back, you can see that it definitely added a refined mesh in those areas. So we're going to just use this and see what happens as a mesh. We may come back and modify this. This may need to be extended depending on whether there's backflow conditions. Hint, there will be, so we will end up extending that, but I'm going to show you as if you were running the simulation, you'd try a value and then have to go change it. So you're going to have to end exchanging this, but it's not going to take very much effort because we have everything set up to change with it based on percentages. So anyway, so when we go to change the continua, this is where you're going to select all your models. So if you expand this out, right click and select models. We want this to be a steady flow, but you'll notice initially actually that it has enabled the model as 2-dimensional. We don't want that. We actually want it to be axisymmetric, and there is a difference in the STAR-CCM. So if you uncheck that and change it to axisymmetric, if you don't do that, when you're applying your boundary conditions on your region, you're not going to have axis as an option. So if you don't have axis as an option, you forgot to unclick 2-dimensional and change it to axisymmetric. Anyway, so we want a steady flow of a liquid. We're going to go with segregated flow, constant density, laminar. You could have changed at any of those points. So if you didn't have laminar clicked, you can change it to turbulent. So here are a bunch of other options. It auto selects the recommended models, but we didn't actually have that happen for any, so we can close at this point. Now, if we expand these models, most of these are what we kind of want already, but the liquid, it's automatically, its default is H2O. We can right click on this and rename it, and we're just going to call it fluid because I'm going to change its material properties. I'm looking for a Reynolds number of about 1,000, and since the diameter is 0.01 meters, I'm going to change the density by expanding this to 1,000, and dynamic viscosity mu. I'm going to change that. It's going to be very viscous, so I'm going to change it to 0.1. So essentially, when it's at 1,000, that 0.1, if my inlet velocity is 10 meters per second, that's going to have a Reynolds number of 1,000. You can change any initial conditions or reference values. We're not going to need to do that for any of this. What you can do when you expand this region down here, we can minimize all these models because we're not going to be using these anymore. So expand these regions, expand the boundaries. You'll note that all these boundaries that we've changed and renamed are available here. For axis, you'll note that the type is wall, so you can expand this and select axis. Again, this won't be available if you if you don't disable 2D and enable Axisymmetric. So we can make that an axis. The outlet, we can change to a pressure outlet, and an inlet we can change to a velocity inlet. A velocity inlet, I'm going to change the velocity magnitude to 10 meters per second. And so that's how we're going to have that set up. So now what we're going to do is add some monitors for some stopping criteria. If you expand the stopping criteria, solvers, we're not going to change any of these. You can change by clicking on here any of the under relaxation factors. If you actually want to change the solvers themselves, what you actually have to do is you have to go all the way back up to the physics under the continua, go to models. For the segregated flow, like for convection, you can change that to second order. We're just going to keep it at second order right now. That's just an aside. And also, same with these under relaxation factors. The smaller they are, the more stable the solution is, but it takes longer to converge. We're not going to change any of that right now. So we're not going to change any of the solvers. But for the stopping criteria, we're going to change the maximum steps to very large because we want it to keep solving until it reaches the solution that we want, essentially the low residuals. So if you right click on here and create new criterion from a monitor, we're going to create one for continuity. We can click OK, and it'll say a minimum limit. If you click down here, we're going to make the minimum limit on the continuity of residuals pretty small, so 1 to the negative 12th. We're also going to make that, see that right here for a logical rule, we want to change that to and. Essentially, if we don't change it to and, if one of the monitors that we add, because we're going to add a monitor on the X and Y momentum, if one of those monitors reaches the limit, it'll stop. So we want it to be, if it was at or, but if it's at and, all of the criteria need to be met for it to stop. So if we right click, create a new criterion for monitor for the X momentum, change the logical rule to and, change the minimum limit to the negative 12th, click out, and create a new one from the monitor on the Y momentum, minimum limit of 12, and again the and. All right, so now that we've added the monitors, what we're going to do is we're going to add some stuff. You could actually add any of this later, but essentially some scenes, we're going to have those set up so that we can watch it as the solution is actually running. So these scenes down here, we can change these. We can add these at any time, even as it is running. I'm going to set it up beforehand instead of afterwards or during. So if you right-click New Scene, we want a scalar function. You notice down here it's scalar. We can right click on that and rename it, and I'm just going to call that velocity because that's what the scalar function is going to be. So if we extend that, expand the displayers, we want the extend scalar again, the scalar field, right as you're going to here, select the function, the dot dot dot. We're going to just add that to velocity, and we're just going to have a velocity magnitude. We can click OK. If you click up here, all the way up here, actually, you'll see it'll be velocity magnitude. Now you'll see that the parts for the region, it's already set up for the general region. You can select it for different things if you want, but it's going to be already for the general region. As you can see, the velocity and magnitude's nothing showing up right now because we haven't solved anything. So what we're also going to do, just because we're going to be checking the velocity downstream, we're going to create some line probes. So what we're going to do is create some derived parts. So if you go all the way back up here and right click on derived parts and new part, we want a probe, we want some line probe. All right, so we're going to add these probes in different locations. Point 1 is essentially going to just start at 0, 0, 0. Then point 2 is going to look something like this. So extending all the way up and down there. The resolution that we're going to set is 1000. That's essentially allowing 1000 points between these 2 points. So essentially what we're going to do is take this line probe here, put one here, put one here, put one here, as far downstream as you want, and however many you want. But anyway, so that's all we want for that line probe. So we can click create, and we can close. All right, so for that line probe, if you look at the derived parts, which, sorry, was down here, you will be able to expand that, and you can see it right there. So you can also edit the resolution or any of the points down here, but actually I'm going to teach you a nice little trick. If you right click on this and copy it, and we can paste it and continually paste several of them, and it's going to have the same, essentially all the same information as the first one. So if we rename these, so this is line probe, we're going to call this x equals 0. And the next one, we can right click and rename x equals 0.3. And for that to be x equals 0.3, we can actually change x to equal 0.3. You'll note that it's changed, that now it's x equals 0.3. You can do the same thing for line probe 2. Cut a copy of the copy, rename it. So you can say x equals 0.6, and change the coordinates so that x equals 0.6. And we're going to do one more time because I copy and pasted it that many times. We're going to change the x coordinates to 0.9 and right click on it and rename it to x equals 0.9. All right, now that that's set up like that, those are all the probes. What we're going to do is we're going to create a plot of those over the probes. So if you scroll down here to plots, it's going to show you a residual plot automatically, but if you right click new plot and create an XY plot, the X type, since we want it to essentially be going up and down vertically, we want the direction for the vector quantity to be 0 and then a 1 in the Y direction. And the X types, if we expand this, expand it some more, we want a scalar function, and we want that to be the scalar function of essentially the velocity, and let's give it the velocity in the specific u direction. So the u velocity or the direction in the x. You can click OK. If you go back up here You'll see that parts, I didn't assign them. So the parts that you have to assign to this, you click the dot, dot, dot. We're going to assign that plot, and it's going to do a plot for all three of these. So if you can just click them all. You see that the legends up here, again, it hasn't solved anything, so nothing's going to show up. So we can minimize that. And so now we can start running. So you can step through it by clicking this button. It'll just take one step, or you can run it a bunch of times. But before you do that, you might as well save it. So you can file, save as. We're gonna just call this tutorial. And might as well, as soon as it's done, it's saving it and it says finished. And now we can start running it. The residuals will stop up. You'll notice that it's not extremely steady. You'll notice that here, right here, I'm getting continual reverse flow, reverse flow, reverse flow. Lots and lots of reverse flow. So it is still slowly going down and converging, but reverse flow is never a good thing. So what we're going to do, if you take a look at the velocity for essentially all of these, take a look at these. You notice that for some reason, I have the select function up here. I don't remember when I clicked it. I might have accidentally enabled it. But if you expand your velocity, you actually see probe scalar right here. And we can just delete that. So we don't really want to see that on that picture. So you notice again, if you look, the residuals are going down. But again, there's a whole bunch of reverse flow. It is giving you a decent a decent looking jet. You can see it's developing the flow, so it starts all uniform, and then essentially you can see it's developing the flow, so there's a higher velocity here and a lower velocity near the wall, which is decent. But again, if you look, the residuals are going down. When the residuals reach down there, if they actually ever do, the solution will stop. But what we're going to do to stop the reverse of the flow is we're going to essentially extend the geometry much further. We're going to keep the mesh as it is, and we're only going to keep data from that range. But if we extend it much smaller and with larger cells, it's not going to take much longer, and it's going to enable the backflow not to exist anymore. So you see the stopping criterion. All of these stopping criteria has been satisfied. Notice the and. So again, it looks decent, but if you look at the XY plot, you'll note that it's kind of clunky. That's because whenever it takes a probe in the same cell, it's going to be essentially whenever it takes it in the same cell, it's going to give you the same value. So to kind of fix that and make that look a little bit better, when you expand this for the Y type, you can actually change it to smooth the values. So if you check smooth and zoom it, you can zoom in and out with the scroll of your mouse, which I guess I've been doing. But so now that it's smooth, you can see that it looks, again, this looks decent. But we're not going to analyze this. We're going to kind of prevent the reverse flow because that's not really great for our simulation. We don't know where it's affecting the solution downstream. So what we're going to do, we're just going to overkill it. If you go to the pipe length, instead of 100, we're just going to add another 0. You notice there's a bunch of exclamation points all through here. If you right click and update it, if you look at the geometry scene, it's now much longer. Badge for 2D meshing, we can execute it. Automated mesh, we can execute it again. Now again, the way we have it set up is, since we don't have the refinement still only have the refinement in this area, everything in these cells are going to be very long. They're going to be much larger. It's going to expand very quickly. So you're going to see an example of what that looks like very shortly. Once it finishes doing the mesh. Alright, now you see it's gotten very large. Again, we haven't added many cells. We've just extended this really far. And so, but ultimately, it only has added 7,000 cells, which isn't really that many at all. Having added 7,000 cells, what we're going to do is we can run through this simulation again. You can continue running it, and it'll kind of interpolate the values from where you started. But what we can do is actually go to solution, clear the solution field. So we're just going to start it over again. So it's going to start with nothing, and then you can see it develop again. So as we click run, you can see essentially the jet progressing downstream. You notice that we're not really having a problem with backflow, and if it ever does appear, it quickly goes away. So there's some backflow, but it's gone. Well, there's still actually a decent amount of backflow in trying to solve it, but then it goes away. Yep. So the backflow is gone. If you look at the residuals, it's very took a while. That's where all the backflow was happening, and now it's going to go down pretty quickly to the values that we want. So we can just wait for that to happen. All right, so I'm going to stop it right here because for some reason we're undergoing some cyclical motion for the residuals down here. You notice the residuals are down in the negative 12th, negative 14th, negative 13th range. It hasn't quite converged yet. But these numbers, as it's running, I notice is not actually changing. So you can actually run through and actually be watching these. So that's actually what you want to be paying attention to is your solution changing, and residuals of 10 to the negative 11th versus 10 to the negative 12th. Not really that big of a difference. So anyway, so I'm going to stop it right there. And so again, here's your velocity profiles. Very similar. You can have your residuals, your plot for your velocity profiles. If you want to take a better view of this, when you expand the XY plot, you can actually go down here and expand the axes, the bottom axes. If we want to make the maximum 0.0, let's make it 0.06. You can see what it looks like. So this is what it looks like. At those points. If you wanted to export them, what you can do, you can right click on this and export. It's going to essentially export it as a CSV. So we're just going to call these tutorial files, tutorial data. And we can save. So now if we open that file, we can take a look at them, at the data. So if we open the CSV, so let's go, I saved it in documents, tutorial data. Yep. All right, so here are all your essentially probe locations. Here's the probe location, and here's the velocity at that. So you can analyze your data. Now make sure when you're running your momentum and mass flow conservation that you're only going up until the velocity essentially is negative. Not negative, so it's positive, positive, positive. At this point it's going negative, so essentially you're going to see a recirculation region. When I do the streamlines, it's going to seem a little bit more clear, but there's recirculation. If you look at this velocity, there's going to be recirculation in this region, so there's going to be flow going back in this direction. And if you try and because there's entrainment obviously coming down through here, if you try and model that, the flow going this way, including that in your mass flow rate for the jet might not be increasing because it's going to be subtracting, and then your momentum flow, you might actually think that it might be increasing because when you're doing the momentum, you're calculating in that direction as well because it's u squared. But anyway, so just make sure you pay attention to these negatives and don't, when you're doing these, your trapezoidal rule on this to kind of calculate momentum and mass flow, don't include the negative. After it goes negative, stop using that data for the recirculation. So I mentioned before about the streamlines, so I might as well show you what that looks like. So if you go to derived parts and you right click on it, essentially the first thing we need to do is create a streamline source. Kind of treats them more like streamlines where it essentially inputs from a source. So the first thing we want to do is create a new part in isosurface. The isosurface that we create, what we want to do, we can just, we want to select the scalar. The scalar that we want to create, we want this to essentially just be at the position of y, y equals, we're going to say 0.1. So position, laboratory, y, and the value that you're looking for is 0.1. You can create the isosurface on the region and close. And you see that that's actually where the isosurface is. And so then if you right click and create a new part in the streamline, what you can do is create the seed part. You can use that isosurface, click OK. We're going to change this to, we're going to say 15 and 15, and then click create. At that point, you'll see that it has the select function if you close. So if we actually change this onto the geometry screen, it's much easier to see. And we can click, actually let's just create a new geometry. That way that geometry was created way back when we had it still as 3D. So this is that, and then if you show the derived parts for the streamlines, you can see that the streamlines are being entrained into the jet, and you see that there is this recirculation region going on over here. So if you're calculating the streamlines, there's a bunch of fluid going in this direction to be entrained, and this might be subtracting from your mass flow rate that you calculate for the jet. So again, you're only going to want to take that data point up to right there. Once it starts turning around, you don't want it anymore. But anyway, so that's how you create some streamlines. You can notice that the streamlines, the recirculation stops after a while, and it's just going out the end. So that's how you would end up creating those streamlines. From there, again, you can edit any information that you want by creating new scenes. So if you create a new scenes, like I did for the velocity, you can create it for pressure or anything like that. But that's all I'm going to do for the day. You might as well save your work. You have everything exported. We have everything exported, so we can do that. And thank you very much for listening to my tutorial. If you guys have any questions, please let me know.